All right, let's do another example here. Example 2, find antiderivative of x times the sine of x with respect to x. So, how do I know that I'm going to use integration by parts instead of use substitution? I do have a product of two functions inside of the integrand, but sometimes when you're doing use substitution, you also have a product of two functions, right? Okay, however, with use substitution, the product of two functions, well, it came from the chain rule, and that second function is usually the derivative of the first one. So, like if you tried to use a use substitution as, let's say, it was sine x, take its derivative, du is equal to a cosine x, we don't have that in here. All right, so no, doesn't make sense. Okay, so maybe you try a different part. Let's say that we let u equal to x. Okay? And then du would be equal to just a dx. Okay, well, we have that thing covered. And then if you go to try to rewrite this thing, I would take the x out and replace it with a u, and I would replace this one with a u, and then the dx with a du. And then all you've done is switch the variables from a u, from an x to a u, right? Totally unhelpful. What? Are you kidding me? All right, let's be sensible about this. So, also notice that what we do have is an algebraic function right here, and then we're multiplying it by a transcendental, in this case, a trigonometric function. That is a pretty good indicator that we're going to do integration by parts. Let's write down lipit again. L-I-P-E-T, lipit. All right, so on the little continuum, we have our two parts. We have an x and we have a sine x. X is our power function, and then we have, let's say, our sine x, and the sine x is a trigonometric function. Okay, so further to the left, that's going to be our u. So for us, that is, wait, hey, choose the right color, our x. And then further to the right, that's going to be the sine x dx. That's the transcendental function, which is going to be our dv. What do we do next? Well, we got to take the derivative of the u function, and we have du is equal to just simply dx, right? The derivative should get simpler. And now I choose the other part, the transcendental part, sine x, to be my dv. And now take its antiderivative, broop, broop. Oh, what was that? I don't even know. All right, so taking its antiderivative, I get v is equal to negative cosine x. I do get a plus c. Ignore that for right now. We'll take care of it in the end. Okay, so my integral should be equal to uv. So I need to take the product of these two things. I'll bring the negative right out front. X cosine x minus the integral of, and now our original integrand is, I'm going to say the diagonal from the u to the dv, and then it's the other diagonal that we're exchanging it for. So that's going to be a negative cosine x dx. All right, and now notice that our new integral doesn't have a product in it anymore. I'm going to take this negative and cancel it out with that negative. Boom, boom. And let's copy the first part down. Antiderivative of cosine is positive sine x, and then here's where we put our plus c. So let's say that we're going to check this, which is a good idea, especially when you're first starting out here. Let's check it by taking the derivative of this answer. And I should go back to x sine x, right? Okay, so using the product rule, I'll tag the negative sign with the x. The derivative of the first function is just going to be negative times cosine, so negative cosine x. Okay, and then plus the first one times the derivative of the second one. So when I take the plus the first function, negative x, times the derivative of the second one, derivative of cosine is a negative sign. And then, of course, our two negatives are going to cancel each other out. And then take the derivative of the second piece here, which is a positive cosine x, and then derivative of c is just 0. And now we can see the cosines here cancel. Come on, cancel. There we go. And then we're left with x times the sine of x which, if I'm not mistaken, is our original integral.